elements can generally be grouped into a series of 8 or 18 groups of different types of electron voltages and sharing different electrons and shells. For example, group 0 elements are elements that have a full electronic shell. Thus, the elements have to group no tendency to lose or gain or share electrons. Thus, the elements in this group are chemically inert. Group 1 elements, the groups in this element have 1 electron in their outer shell. Each element in this shell has a tendency to lose a single electron to form a singly charged positive ion, which is stable electronic configuration in its neighbouring noble gas elements in the periodic table. Subgroup 1a are the alkali metals and subgroup 1b are the transition metals. Alkali metals include lithium, sodium, potassium, and group B include things like heavier copper, silver, or gold. Hydrogen is also included in this group because there's a single electron in the outer shell. However, hydrogen has none of the metallic properties of the alkali metals. Group 2 elements. The elements of this group have 2 electrons in their outer shell. Thus, the element have tendency to lose 2 electrons to form a doubly charged positive ion. The elements of this group are chemically reactive. Subgroup 2a are the alkali earth metals, and subgroup 2b are the transition metal elements. The alkali earth metals will be the commonly found beryllium, magnesium, calcium, or strontium, while transition metals aren't as commonly found, such as zinc, cadmium, or mercury. Group 3 elements are the elements that have 3 electrons in both the outer shell. The electron configuration of these orbitals are 2n²np³. Thus, each element of this group has a tendency to lose 3 electrons to form a triply charged positive ion, which is a stable electronic configuration, like the last, of its nearest neighbouring noble gas elements in the periodic table. Quite like Group 2, it has 2a, the transition earth metals, while it elements configuration of lanthanum and their most outer electronic orbitals when the third orbitals are being filled from going to the element. These transition earth metals are called lanthanides. Subgroup 2b are the main element groups such as boron, aluminium, gallium, indium, and thallium, possibly more commonly found than the other lanthanides. Group 4 elements are elements that have 4 electrons in their outer shell, thereby gaining a stable electron configuration by getting rid of the fourth to create a quadruplet of electron charging next to its neighbouring noble gases, quite like the last 3 groups. So we have subgroup 4a, which are transition metal elements, and subgroup 4b, which are main group elements. Like the last one, main group elements will be more commonly found, possibly heavier, such as carbon, silicon, germanium, tin, lead. And then the less commonly found or bombarded, such as titanium, zirconium, thorium, hafnium, aren't as commonly found. Group 5 elements also have 5 electrons in their outer shell, thus the element has a tendency to gain 3 electrons to form a triply charged negative ion, which is stable configuration nearest to noble gas elements. I think you're seeing a pattern by now. But subgroup 5a, transition metal elements, are vanadium, niobium, tantalum, and protactinium, which are also not part of the main group of elements, which is nitrogen, phosphorus, antimony, bismuth, and some elements like that. They'll be more commonly found, possibly have a more common purpose and tendency than the half-life vanadium, niobium, tantalum, and protactinium. Next is group 6 elements. These, quite like the last one, follow the same pattern with 6 electronic shell. Thus, the elements have a tendency to gain 2 electrons, causing them to have a stable electron configuration, which is nearest noble gaseous elements in the periodic table. So group 6a transition metal elements are chromium, magnesium, tungsten, uranium, and of course differing from the main group elements such as oxygen, sulfur, selenium, beryllium, or polonium. Group 7 elements once again have 7 in their outer shell, thus they have a tendency to gain a singly charged negative ion, which is a stable electronic configuration next to its neighbouring noble gases. Of course, subgroup 7a is the transition metal elements, quite like the last few, and 7b I should say, is the main group elements such as fluorine, bromium, anium, astatine, or astatine. Kind of things you would have heard of, opposing to technetium and rhenium. When we go into group 8, these contain the triads of elements in the centre of the periodic table, such as iron, cobalt, nickel, ruthenium getting higher and more nuclear charged, rhodium, palladium, and then at the very bottom of the spectrum, at the bottom in the middle, you have lithium, iridium, and platinum. Well, that's all our groups we have for today. If you like the video, please like and subscribe, and as always, thank you for watching.